Creating visualizations, we have seen so many types. But do you ever wondered how could I create a chart or a graph that could be helpful in understanding the complicated relationship between my data? Are there any charts that we could explore and understand relationship between each and every data points in my data? So if you are looking for one chart for that, one library which could create multiple visualizations for that, then NetworkX is going to serve all your purpose. Let's get started. So the first thing that you need to remember when it comes to NetworkX chart is it is widely used in recommendation systems. In Amazon or Flipkart, whenever you search for a particular product, you will be getting suggestions based on what you search for. And when you go back to the same website or the same e-cart, the same e-commerce website or the application, you'll be seeing suggestions based on what you searched for. And when you're about to click on buy, you'll be seeing the options like frequently bought together. How it is happening? What is happening at the back end? So each and every data is having some connection there. So to understand the connection between that data, we are going to create visualization. Creating that visualization, we are going to use this particular NetworkX library. This kind of library is specifically applied for recommendation systems and fraud detection and creating graph of machine learning algorithms. For working with this, the first thing I need to do is I need to import NetworkX library into my coding environment along with Matplotlib for creating visualizations. Then I am creating a blank space using this RC params with a figure size of 6,6. The first chart that we are going to create is social network graph. This chart is specifically used for understanding who is connected to whom. In business scenarios like recommendation systems, specifically in Amazon, if I want to understand how one customer who bought this also bought some other product. So based on this, I can suggest another customer, they are about to buy the first product that my first customer was purchasing. In that scenario, I could use this to understand the relationship, and based on that, it could give the suggestions. In Netflix, based on how a particular person from a location is watching movies, another person from the same location or locality might also be interested. So based on that, I could give suggestions in Netflix. That's how you get suggestions when you watch a series or movie. This graph is specifically used for recommending based on connections, not just based on averages. Specifically on influencers or key customers, if I want to understand who's my key customer, how is their relationship in that scenario, I should be using this social network graph. It is commonly used by many e-commerce applications, social media, and content platforms. The first chart for creating this one, what I'm going to do is I'm going to import the library, right? I already imported it, so I'm going to use that. By using that, what I need to do? Now look into the coding part clearly. First, I'm doing G is equal to NX graph. Here, NX means the NetworkX library, which I imported and kept. So here, graph is for creating an empty undirected graph first. Then I'm giving G.add edges. This specifically adds multiple connections or edges at once. Followed by that, when I give that list of all names, alive Bob, alive Charlie, Bob, David. Likewise, this part of the coding build relationships. Ali is connected to Bob, Ali is connected to Charlie. Likewise, it is going to build relationships. Then when I'm giving nx.draw, this is used for drawing the graph. So when I give nx draw of G, it is going to draw my first graph. Followed by that, I'll be giving with labels equal to true. Here, when I give with labels equal to true, it show me the names. It will be showing me the names like Alice, Bob, and etc. Here, I'm giving note size equal to 2000 because it will be making my notes bigger. The color is also specified inside by using note color. And finally, when I give plot.title, this title is completely customizable. And after giving this, my chart will be automatically created like this. Using this chart, I can easily see to how many members allies got connected to. and how many members David got connected to. So what is the common relationship between them? How many, see in this Eva alone got connected to David. This particular person just have one relationship. Apart from that, another other people are having more than one connection, so that I can understand from the start. So for understanding relationship or complicated patterns, I'll be using this social network graph. The second chart that we are going to see is directed and weighted graph. It is specifically used in a scenario when I also need to see the direction. In my chart, why? First of all, I need to see the direction. So let me give you some example. If you are working in a cybersecurity based project, to detect if that person is a fraud or not, or where this part of fraudulence itself is happening, we want to observe and figure out that this chart could be applied there. Let me explain how. So when money flow is happening, it will be generally starting from one person and it will be moving to another person. That money will be moving to another person, right? So everything is linked here. So that is how, if I want to see how a particular person could be a fraud. So another person could be a salesman, one person could be a customer, one person could be a wholesaler or anything. So in between, if a fraudulent activity is happening, who is that fraud? To observe that, if I'm using a directed graph, I can easily understand. Specifically, this is applied when I want to detect the fraud. It's about money movement paths and it's about tables that hide circular money flows. So banks are specifically using this. They are using this more often because if some fraudulent activity is happening, sometimes it's not about fraud activity. Sometimes you might accidentally transfer your money to a wrong account number by typing one or two wrong numbers. So if that happens, bank could help you in getting your money back if they use this graph. So now let's look into the coding part and try to understand how this works. First thing, what you are going to do for creating this graph. The first line of coding is nx.digraph. Here this is specifically used for creating a directed graph. Di means directed graph. So it is like when it gives A directed to B, it is completely different from B directed to A. The direction says a lot here. The next line what I'm giving here is I'm giving dx dot add weighted edges from. So this is about adding directed edges with weights. Here followed by that I'm giving source comma target comma weight. What is that? That A is our source, B is a target and 5 is a weight. Followed by that A is a source, C is a target and 2 is a weight. Likewise, it is applied for every single rows here. Here, this weight value, it can represent cost, it might be distance, it might be time, money or risk level, it might even be data volume. Followed by that, I have given POS, right? So that particular value of weight, it differs completely based on scenario, on the domain that you are working in and based on the problem that you are solving. Here I'm giving POS equal to nx dot spring layout of DG, right? It is going to calculate my node positions. Here it will be using spring layout algorithm. So nodes behave like springs here and it got connected by pulling them closer. So unconnected nodes will be pushing them apart. So it automatically makes graph look organized. When I give weights equal to nx dot get edge attributes, it will be extracting all edges weights, then store them into a dictionary. For creating a chart finally, I am giving nx dot draw. Here in nx dot draw, DG is about creating a graph and POS is for position layout. Labels equal to true because I want the name for every single node that I am going to create. Then I'm giving node size equal to 2000 because I want bigger nodes where I can place the name of each and every node. Node color is customizable. Then I'm giving arrows equal to 2 because I want to see the visible arrows. Followed by that, I'm giving nx dot draw network edge labels, because here it is going to add numbers on edges and it will be displaying my weight values along with that. Then it uses positions. That's why I'm giving this way, like pivots. And finally, when I give a title and I give plot.show, this will be created like this along with the directions, and these numbers represent the weight. So based on the scenario, based on the domain, based on the problem that we are solving, this value of weight, we can understand based on that. It might be anything in data. The next chart that we are going to see is community detection visualization. So this is specifically for understanding in a group of all data. Is there any group in a set of all data? For example, if I'm having 1 lakh crores, is any data connected among groups? To understand that, I'll be using this community detection visualization. So in some business scenarios, how this chart is being used. In customer segmentation, I can use this. So instead of just segmenting by some categories like age or income, if I could segment by interaction patterns, how customers are interacting. So if a particular customer is purchasing this product, they might purchase another product, right? So based on that, if a second customer coming and purchasing the first product, there are possibilities they might purchase the same second product. So to understand that kind of patterns in my data, that kind of interactions happening inside, and to understand who talks to whom and who buys similar products, for understanding this, I'll be using this chart. Then in fraud rings, specifically, what is it actually? Generally, fraud will not happen. It's a single person. A single person cannot be a fraud most of the time because they are proud of doing it. A group of people will be discussing about it, planning about it, and they'll be doing some fraudulent activities. So it generally happens in groups. So this particular community detection chart is going to expose you the collusive sellers and fake review networks and scam call groups. So fraud activities can also be figured out, and also some fake activities that's happening, like some for products. For some products, you might have seen some fake reviews. If you even go and see for any healthcare or skincare products, you might have purchased a product that didn't serve its purpose. But if you see the review, that is like, wow, such an awesome product, that might be a fake review. That might be a paid review. So to understand how it is happening and what is the relationship among the people who are giving fake reviews. For that, I can use this chart. So that is why it is used in banking, insurance, and marketplaces. Now let's try to understand how this coding part works. The first thing that I'm doing here, apart from what I did in another set of all coding and another charts creation, is first thing I'm going to import the library for using an algorithm. I'm giving from networks.algorithms.community, import greedy modularity communities, right? So here, this community is used for finding clusters or group in my data in a network. So it generally groups all my nodes that are most strongly connected to each other. So it is used for detecting communities inside my graph. So when I give community is equal to list of that community part, it is used for running the algorithm on graph G. So it will be converting my result into a list. So color map is equal to open and closing bracket, right? This for creating an empty dictionary. Then I'm giving colors equal to the possible colors that I do want. First community, show me as red color. Second community is blue. So each and every color I'm specifying here is for showing me the community types. So as per the type of communities that you could have, you can change the count here. Then I'm using the first for loop. This for loop is used for looping through each detected community. So here I use an index number. It starts from 0, 1, 2. So community is generally here a group of nodes. So inside the loop, I'm giving for node in community, right? So here, for each node inside that community, it assigns color based on community index. The result could be like color map is equal to Alice is red, Bob is red, and Charlie is from blue category. he belongs to that community likewise. So now every node has a color. Then I'm giving node colors equal to color map of node for node and G dot nodes because it creates a list of colors. So order must match the G dot nodes. This ensures correct coloring during the drawing part. Then I'm giving nx dot draw. Here, start from the coding. I'm going to draw the graph. That's why I'm giving G. Then I'm giving show me the labels. That's why with labels equal to true. Then I'm giving the node size of 2000 because I want a large one. Then I'm giving color, node color is equal to node colors because I already specified, right? For this community, give me red color. For this community, give me blue color likewise. And finally, I'm giving the title of that community. I mean the chart, and I'm creating this chart. That's it. So based on this color, I can easily understand which community they belong to. So Eva and David is coming under one community, and Bob, Alice, and Charlie is coming under another community. Likewise, I can easily see this chart and understand. The next chart that I'm going to see is shortest path visualization. This could be used in most of the scenarios. So if I want to see, let's consider in a business place, they are selling some products to customers directly. Do you ever thought of where this product is coming from? Only in very few places they are getting it directly from manufacturers, but in most of the places there is a path that it is traveling through. Before that, it might be it might be at a place where wholesale products were being sold, and before that it might be at a place where another wholesaler is there, and before that only that manufacturer will be there. So that is why some products cost is high, and in some shops the cost of the product is less. So based on this particular chart, I can easily find what is the shortest path I could get my products. So in such scenario, I'm not telling this is the only scenario. We do have so many scenario likewise. That is why I mentioned here in supply chain optimization. Factory to warehouse, directly to store. So shortest path, what it means here, it is about lowest cost or time. If I am taking the shortest path of directly getting it from manufacturer and selling it a particular shop, my customer could buy a product at the very low cost. So here in network failure analysis also I can use this chart. If one node fails, what is the next best? If I'm thinking this is a good manufacturer, or I'm thinking this from this person only, I could get it from a best price. What if I found that no, it is not? I can definitely find another path, right? So that is also possible with this. So that is why it's used in logistics, telecom, and delivery platforms. Now let's try to understand the coding part here. So the first thing that I'm giving is I'm giving dot spring here. So what it means and why do I need this first of all? I am specifically giving dot spring layout and g is equal to g comma seed is equal to 42. So this is something we have already seen, right? Like this line of coding I'm saying. Do you remember? In G part we have already seen. But spring layout here it is used for generating the positions for nodes using spring layout. So it generally generates positions for nodes using spring layout. Here seed is equal to 42 means I'm making the layout consistent every time you run it. That is why you need to give the fixed value of 42. So this ensures stable visualization. Then I'm giving shortest path is equal to nx dot shortest path. This finds the shortest path between Alice and Eva. So here the starting point, source is Alice and target is Eva. So this default algorithm of BFS will be used here. There is a default algorithm that is hidden inside. When I call this line of coding shortest path is equal to nx dot shortest path, the algorithm of BFS will be used here. So it generally returns a list of nodes that is in path. So what might happen inside? Inside it may be like Alice, Bob, David, Eva. So this is the maximum number of steps that is needed. Then I'm giving path edges. Path edges equal to list of. Then I'm giving zip of shortest path, comma, shortest path 1 is to what happens here. This converts my nodes into edges. But how it actually works? If path is like Alice, Bob, David and Eva, then Alice and Bob, they are connected. And Bob and David, next path. David and Eva, the next path. So here, what could be the shortest path? That is what they will try to understand. So these edges represent the actual path connections. When I'm giving nx dot draw right here, it is going to draw my full graph. And I'm giving the color as light gray because I want all my nodes in light gray color. So this is going to be act as a base layer visualization. And followed by that, I'm giving nx dot draw network edges, NetworkX edges. So here in this line of coding, I'm going to redraw only the shortest path edges. When I give edge color is equal to red, it is going to highlight my path. That is why specifically I am giving width is equal to 3. So this particular line that I am highlighting the path, right, this should be 3 times broader than the usual one. And finally, when I give plt.title and I give plt.show, what is happening? So it is going to create a title, shortest path visualization of my customization. Then I'm giving plot.show. It will be creating a chart and showing me. The fifth chart that I'm going to create is knowledge graph. As similar to how human beings understand what is happening inside and finding the relationship. So let me give some example. Like if a person is having a disease or not, how will you be understanding that? Some symptoms might be there, right? So based on that symptoms, they will go to doctor. So if the doctor confirmed it, they'll be getting treatment. How it is happening overall? They have a knowledge, a person who is having a symptoms is having a knowledge. This symptoms, I need to go to doctor. And doctor will do some exam, like they will be checking out the health of a person. And after figuring out if that particular person is having disease or not, he or she will be giving the treatment. So how everything is happening based on the knowledge of the person, right? As per that, if my chart is also having a knowledge, that is called as knowledge graph. So it might be entity relationship intelligence. So it is about a relationship between every data. That relationship is found because of the knowledge that my system or computer has based on how I trained my system. So see some business scenario to understand how it is happening. Specifically in search and AI systems. It might be Google or Amazon or LinkedIn. So they all use knowledge graphs. That is how if I have a requirement for my job application, if I have a requirement for hiring a person, I can post that on my LinkedIn post and I easily get so many people seeing that and they'll be reacting accordingly, right? So how it is happening? I have a knowledge that for this requirement, I need some person with this qualities and that person is checking out that and if they have the skills, they will be applying it. So that is how it generally works. So it might be applied in product based or branding based. It might be applied in hiring process. It might be applied in disease for getting rid of a disease by going to a doctor and getting a treatment. So this graph is generally used for using the reasoning part of our life. So it enables explainable AI. It is specifically used in enterprise AI, chatbots, recommendation engines, and wherever reasoning is a part of it, this chart could be applied there. Now look into the coding part and understand how it works. The first thing I'm doing is I'm giving nx.digraph. It is for creating a directed graph. Then I'm giving kg.addEdge. So it creates edges from Python to machine learning. So then I'm giving kg add edge, right? It is going to create a relationship in a way. Machine learning is part of AI. So in the first one, I'm giving relation is equal to used for, right? So it means like Python is used for machine learning. When I give the kg.addEdge of machine learning, AI, it says that machine learning is part of AI. When I'm giving .addEdge and AI, healthcare, AI is applied in healthcare. Then I'm giving AI, finance, it means that AI is applied in finance. So first part of my element AI, then I'm adding the relationship is applied in. Then I am calling the second part. So the main concept here is, it's unlike previous graphs, we are not adding weights. We are adding semantic meaning. I mean the relationship type here. That is what we are applying it here. So this makes it as a knowledgeable graph. That is why it is called as knowledge graph, not just the connection graph. Now I'm giving POX is equal to nx dot spring layout of kg because it calculates node positions and it uses spring layout algorithm. So it will be giving my organized graph in a visual way. Followed by that I'm giving edge labels is equal to nx dot get edge attributes. So here it is going to extract the relation attribute from edges. And finally, it will be storing them in dictionary format. Followed by that, I'm giving nx.draw, right? So here, when I give kg, pos, this part, this is specifically used for drawing my directed graph. And it shows me my node names. So node names will be given when I give equal to true and node size equal to 2500. It will be much bigger than the previous ones because for the previous ones we have give 2000, right? Then I'm giving colors equal to light yellow, arrows equal to 2. So because I do want arrows, and I'm giving nx dot draw NetworkX edge labels. So this is for displaying the relationship names on edges. And finally, when I give plot dot title and I give plot dot show, it will be showing me my chart like this. So see, by just looking into the chart, I can understand what and all the relationship is there. So healthcare is applied in, AI is applied in healthcare. You can look into the arrow and confirm how it is working. You should never get confusions on it. So Python is used for machine learning. So machine learning is part of AI. AI is applied in finance. So based on the direction and what is written on the direction line, I can understand the relationship. And based on the direction, I can say from where it is moving on to where. So that is how you can easily understand the relationship between data by using a knowledge or reasoning ability using this particular chart knowledge graph. So I believe you clearly understood how to understand a complicated pattern that is hidden inside a data using this particular NetworkX library, and you got clarity. I believe you got clarity on doing this coding part as well. If you have any doubts, without hesitation, drop them in comments. Bye for now. We'll meet you in next amazing video.